In this video, we are looking at finding areas between curves and lines. The first question, we've got the graphs of y equals 10x minus x squared minus 9, and we've got the line y equals 12. They intersect at the points A and B. To start with, we need to find the coordinates of A and B. Where two lines intersect, we have simultaneous equations. So if we solve the simultaneous equations, solve these two simultaneous equations, we find the points of intersection. So let's just write, they're both y equals at the moment, so let's make them equal to each other. 12 equals 10x minus x squared minus 9. We want to solve it, it's a quadratic, we're going to make it equal to 0. I'll move everything over to the left side. So we've got x squared minus 10x plus 21 equals 0. We can solve this by factorizing. X minus 3, x minus 7. So x is equal to 3 and x is equal to 7. The y coordinates are going to be 12. So we have 312 and we have 712. So that is the answer to part A. We've found the coordinates of A and B. Part B, find the area of the finite region bounded by the line and the curve. So if we integrate between 7 and 3, we will find this total area. So straight down from B, straight down from A. We'll find that total area, but we don't want the whole area. We're going to have this extra rectangle here, which we can take away. So we've got a rectangle with a base of 4 and a height of 12. So the area of that rectangle, 4 times 12, 48 units squared. So let's find we'll integrate. So we're going to have the integral between 7 and 3 of 10x minus x squared minus 9 with respect to x. That's going to give us that total area. And then if we take away 48 from that, we will be left with the area in between the line and the curve. So let's integrate, add 1 to the power, divide by the new power. So 5x squared minus a third x cubed minus 9x. And that's between 7 and 3. So substitute in 7, substitute in 3, and take them away. So 5 times 7 squared minus a third times 7 cubed minus 9 sevens. Take away 5 times 3 squared minus a third times 5 cubed minus 9. Nope, a third times 3 cubed minus 9 threes. And then we'll take away 48 from that answer. 5 times 7 squared minus a third times 7 cubed minus 9 sevens. Take away 5 times 3 squared minus a third times 3 cubed minus 9 threes. And we get 176 over 3. So we've got 176 over 3. That's the total area. We need to take away the 48. So minus 48 from that answer, we get 32 over 3. So that's our area, 32 over 3 units squared. A question for you to try, pause the video and give it a go. So again, we need to know where the line intersects the curve. So we'll solve the simultaneous equations. So we have 6 equals x squared minus 12x plus 38. Make it equal to 0. and factorize. So we've got x minus 4 times x minus 8. So x is equal to 4 and x is equal to 8. And the line's y equals 6. So the y coordinates are both 6. So we've got 4, 6 and 8, 6. This question's a bit different. So if we find the area under the curve this time, if we find the area under the curve plus the area between the curve and the line are going to add up to make this rectangle. And the rectangle goes between 4 and 8, so it's 4 wide, 4 to 8. It's 6 tall, so the area of the rectangle is 4 times 6, so it's 24 units squared. So if we want the red area, we can do the rectangle, take away the green area. So if we integrate between 4 and 8, we can find the green area. 24 minus the green area will be the red area. So to find the green area, it's the integral between 8 and 4 of x squared minus 12x plus 38 with respect to x. The calculator will do this for us, so we need to know how to do the process, but once we can do that, we can check our answers on the calculator. So between 4 and 8, we get 40 over 3. So 40 over 3 units squared is the green area. We wanted the red area though. So to get the red area, it's 24 minus 40 over 3. And we get 32 over 3. And again, it's an area, so I'm going to write units squared. The graphs of y equals x plus 2 times 5 minus x and y equals x plus 2 intersect at the points A and B. We need to find the coordinates of A and B to start with. So the coordinates of the points of intersection are the solutions to the simultaneous equations. We've got these two equations to solve simultaneously. They are both y equals at the moment, so we can make them equal to each other. So we can have x plus 2 equals x plus 2 times 5 minus x. Let's expand and simplify the brackets. 5 times x is 5x. X times negative x is negative x squared. 2 5s are 10, and 2 negative x's are negative 2x. Simplify. So we have 3x minus x squared plus 10. I'll move everything over to the left side and make it equal to 0. So we've got x squared. We've got x take away 3x. So minus 2x. And 2 take away 10, which is negative 8. Now we can factorize it. So we've got x. It's going to be 4 and 2, so x minus 4, x plus 2. So x is going to be equal to 4 and negative 2. So x is equal to 4 and negative 2. There are x coordinates. Our y coordinates, so y is x plus 2. So negative 2 plus 2 is 0. 4 plus 2 is 6. So we've got negative 2, 0, and 4, 6. They are our points of intersection. Now we need to find the area of the finite region bounded by the line and the curve. So this red section here, if we integrate between 4 and negative 2, our quadratic, So our x plus 2 times 5 minus x with respect to x. If we did that, we would get this total area here. So the whole area between, under our quadratic, between the x-axis and the quadratic. We only want the red part though. So we have this extra shape here, which is a triangle. And we can work out the area of the triangle. It's got a base of 6, and it's got a height of 6. So the area of the triangle is half times the base times the height. Half of 6 times 6 will be 18. So if we do our integration and then take away 18, we'll be left with the area between the line and the curve. So we could, I'm going to use the calculator to do the integration. If we did it manually, we'd expand the brackets, add 1 to the power, divide by the new power, and then substitute in 4, substitute in -2, and take them away. But I'm just going to use the calculator here. So x plus 2 times 5 minus x between -2 and 4. That's got an area of 54. The total area is 54. We're going to take away 18, which is 36. So we've got 36 units squared. One for you to try. See if you can give it a go. So to start with, we need to find the coordinates of A and B again. So that's the solution to the simultaneous equations. So I have 2x minus 4 equals x minus 2 times x minus 5. Expanding and simplifying the brackets, we're going to have x squared minus 5x minus 2x. That's minus 7x plus 10. Make it equal to 0. So we've got x squared minus 9x plus 14. So it's 7 and 2, both negative. X minus 2, x minus 7. So x is 2 and 7. So we've got 2, that's a 2, and 7. Y is 2 times x minus 4. 2 2's take away 4 is 0. 2 7's are 14, take away 4 is 10. So 7 10. So 2 0 and 7 10. Find the area of the finite region bounded by the curve, the x-axis, the line, the x-axis, and the curve. So this time we could find the area under this part of the curve. And then that would make a complete triangle. So the area of the triangle, so 2 to 7, means we've got a base of 5. We've got a height of 10. So half times 5 times 10 will be 25 units squared. So that will be the whole triangle, 25 units squared. Then if we can find the area of this section here, we don't know this x coordinate at the moment. Well, we do. So for our original graph, where does it cross the x-axis? It crosses x when y equals 0. That's at 2 and 5. So this must be 5 here, 7 here. So if we integrate between 7 and 5, our quadratic, our x minus 2 times x minus 5, with respect to x, we can find this part of the graph, right here. And then if we take that away from our 25, from our full triangle, we will find the red section. So let's use the calculator again. So we have x minus 2 times x minus 5 between 5 and 7. So that's 26 over 3. So 26 over 3 units squared. That's that green section. If we do 25, take away that. 25, take away that one, is 49 over 3. So our red section, 25 minus 26 over 3 is 49 over 3. 49 over 3 units squared. Here we have another question. So the graph of 2x squared minus 8x plus 9 and 7x minus 3y plus minus 1 intersect at 1, 2, and 4, 9. So we're being told the points of intersection. They're at 1, 2, and 4, 9. So this is 4, this is 1. Find the area of the finite region bounded by the line and the curve. So if we found the area under the curve, so if we use integration between 4 and 1, we will find that green section there. And we could do the trapezium. So the trapezium, so this whole shape, take away the green section to give us the red section. So we've got 2 tool here, 9 tool here, and a base of 3. So the area of a trapezium is half the sum of the parallel sides times the distance between them. So half of 2 plus 9 times 3. So half of 2 plus 9 times 3 is 33 over 2. So that's the total shape. Then if we do the integral between 4 and 1 of our quadratic of 2x squared minus 8x plus 9, we can find the green section to take away from the trapezium, which will leave us with the red section. So we've got 2x squared minus 8x plus 9 between 1 and 4. So that's got an area of 9. So that's 9 units squared. That's the green part. So to get the red part, 33 over 2, take away 9. And that's 15 over 2. One for you to try. Pause the video, give it a go. Again, we've been given the intersection at 3, 6 here. So we know this is 3. If we found the area under the curve between 0 and 3, so if we did the integral between 3 and 0 of x squared minus 2x plus 3 with respect to x, that will give us part of the bit we need. It'll give us this purple bit. We also want this triangle here. We know it is 6 tall. We don't know its base, but we know it's where the straight line crosses x. It crosses x when y equals 0. So 0 is minus 2x plus 12. So plus 2x to both sides. 2x equals 12. X must be 6. So we have a triangle with a base of 3 and a height of 6. So this area here is half times 3 times 6, which will be 9 units squared. So we do 9 plus our integral between 3 and 0. It's a good idea to do these without using the calculator. So add 1 to the power, divide by the new power, and then substitute in 3, substitute in 0, and take them away. But I'll use the calculator just because I don't want the video to be too long. So we've got x squared minus 2x plus 3 between 0 and 3, which is 9. So we've got 9 plus 9, which is 18 units squared.